This video will show the calibration routine recommended by Brookfield Engineering for our coaxial cylinder geometry accessories. These accessories consist of our small sample adapter, enhanced ultra-low viscosity adapter, thermocell, and DIN adapter. These adapters are all based on defined coaxial cylinder geometry. To ensure your viscometer is working properly when using these adapters, a periodic calibration check is essential. To perform a calibration check with these adapters, you will need a silicone or mineral oil viscosity standard fluid and a water bath. Select a viscosity standard fluid based on the torque range and model of your instrument, the adapter chamber, the spindle, and the rotational speeds that you will be using. For example, an LV torque range DV2 Plus Pro viscometer using a small sample adapter with 13R chamber and SC4-18 spindle has a viscosity range of 1.5 centipoise to 30,000 centipoise, depending on the speeds being used. You do not need to select a fluid based on the material you will be testing. However, many customers choose to do so as a simple verification check. The calibration routine checks the linearity of the spring on the instrument by using one fluid at 3 separate speeds to achieve low, medium, and high torque ranges. This checks the linearity of the spring and the sensing mechanism of the instrument. This being the case, a 100 or 500 centipoise silicone fluid can be used. These lower viscosity fluids are easier to work with and to clean. Use the actual value of the fluid, not the stated value, for the calibration check. Make sure the instrument is level. The viscosity standard fluid needs to be equilibrated at 25 degrees Celsius to get an accurate reading. Fill the chamber with the correct amount of viscosity standard fluid. In this example, the small sample adapter is using 6.7 milliliters of fluid with a number 18 spindle. Hoses from the water bath inlet and outlet will connect to the water jacket inlet and outlet for proper circulation. For proper temperature equilibration, the fluid and spindle all need to be equilibrated at 25 degrees Celsius. The viscosity standards are very sensitive to temperature. The temperature probe on the Brookfield viscometer is accurate to plus or minus 1 degree centigrade. To ensure proper temperature equilibration and accuracy for the viscosity standard, use a calibrated thermometer with higher accuracy. The temperature of the viscosity standard should be controlled at 25.0 degrees centigrade, plus or minus 0.2 degrees centigrade. The thicker the fluid, the longer it will take to equilibrate. For this calibration, we will use a 100 centipoise fluid with an actual value of 95 centipoise. This should take 15 minutes. The 13R chamber we are using supports a temperature probe, allowing for temperature monitoring at the instrument. Based on the spindle you will be using, select 3 speeds that will give you a low, medium, and high torque value. The minimum torque value for a good reading is 10%. A low torque range would be 10 to 30%. A medium range, 30 to 70%, and a high torque range above 70%. This will check the linearity of the spring on this instrument through its full range. With the digital instrument, you can easily find the full scale range by turning on the motor and pressing and holding the auto range button. For example, if you have a 100 centipoise fluid, a full scale range of 200 centipoise will give you 50% torque. Tolerances for calibration are computed using plus or minus 1% of the actual fluid value and plus or minus 1% of the full scale range. Brookfield viscometers have a plus or minus 1% accuracy, but using an accessory like a small sample adapter, an additional plus or minus 1% tolerance for each full scale range is added. The tolerance for your reading is the accuracy of the actual value of the fluid added together with the accuracy of the instrument and the accuracy of the accessory, in this case the small sample adapter. You can perform a calibration check manually and enter the values and compute the tolerances for pass-fail criteria. Brookfield also supplies a calibration worksheet on our website that easily allows you to enter data, computes the tolerances for each range, and gives pass-fail criteria automatically. You can download the calibration worksheet from Brookfield's website at www.brookfieldengineering.com. Going to the link on your screen will take you directly to the calibration worksheet. To see what these tolerances mean, let's look at this calibration worksheet. Enter data in the bold fields. You will need to overwrite the existing data. First, enter the spring torque of your instrument. In this case, this will be an LV. Enter the actual value of the fluid in column A. The remaining fields in this column will automatically update as this value will not change. You can see the 1% fluid value column will update based on this entry. This is the accuracy of the fluid. Enter the spindle code in column D. Again, the fields in this column will automatically update. Enter the 3 speeds you will be running in column E and observe that the 2% tolerance of full-scale range, based on plus or minus 1% instrument accuracy and plus or minus 1% accessory accuracy, in column G is updated. This is the accuracy of the viscometer and small sample adapter at this range. Now, run the 3 speeds you have selected. Record and enter the data in column I. Your results will show up in the box below. The low limit tolerance is column A, the actual fluid value, minus column B plus G, which is the 1% value of the fluid plus the 2% value of the full-scale range. This high limit tolerance is merely column A, the actual fluid value, plus column B plus G, which is the 1% value of the fluid plus the 2% value of the full-scale range. Simply put, if the actual fluid value is 95 centipoise, 1% of this value is 0.95 centipoise. At a speed of 6 RPM, the full-scale range is 500 centipoise, and 2% of this value is 10 centipoise. Thus, the tolerance on the fluid at this speed with this SC4-18 spindle is 95 centipoise, plus or minus 10.95 centipoise. You can see a graph of your results with this worksheet and the tolerances. Select the Calibration Graph tab to view the results. The data points are plotted and upper and lower tolerances shown. In this example, you can see the data points came within tolerance. And that's it. You have performed a calibration check. Remember the important aspects of performing a calibration check: temperature, actual fluid value, torque ranges, and full-scale range. If you find the instrument is not within tolerance after performing a calibration check, repeat the calibration test to ensure everything was done correctly. If your instrument is still not within tolerance, contact Brookfield Engineering or an authorized dealer. A common question is, how often should a calibration check be run? The answer is really up to how often the instrument is used. For example, if an instrument is being heavily used, say on multiple shifts, a daily calibration would ensure accuracy. Daily usage, 5 days a week, may require a calibration check be performed at least once a week. For instruments used less frequently, perhaps once a month or once every few months will be fine. But to ensure the health of your instrument for many years, return this to Brookfield or an authorized dealer once a year for a full calibration, certification, and cleaning. Thank you for taking the time to watch this Brookfield video. Please check the Brookfield website for new videos that may be of interest. If you have suggestions for future videos that could be of help, please email your input to sales@brookfieldengineering.com.